Hello, my name is Alexander Edelman. I'm from Bosch Soft Innovations and I'm responsible for the EclipseIoTVorto project. And I'm going to show you today how you can use this project for rapid prototyping use cases. So let me get started first on tell you a little bit about what Vorto is all about. So with this project, we're addressing three main target groups. On the one hand side, we have the device manufacturers. And with EclipseIoTVorto, we provide them a tool set which allows them to describe their devices with all its characteristics and properties. And they're called information models. And they have a way to import these models as information models into a so-called repository. From there, IoT developers who are in charge of integrating these devices using different IoT platforms can look up these descriptions and generate code for various IoT platforms. The project covers a lot of IoT platforms and a lot of generators IoT developers can use. The platform providers are the ones who help these IoT developers of providing such generators, such blueprint generators, and a system of doing this integration much easier. So this Vorto is basically this entire platform consists of three different parts. So on the one hand side, the repository itself, which manages these device descriptions. On the other hand, the generators to translate these descriptions into different kind of platform representations, and as well as the web editor, which is a new feature of the EclipseIoTVorto cloud platform, which allows them to completely describe a device online. And today I will be giving you the first sneak preview of this web editor, how it looks like. It's going to be launched in July for general purposes, so you can try it out yourself once it is available. So you might ask, what are these information models exactly? So they're actually abstract representations of real objects. So let's take an example of this camera here. This camera consists of different kind of functionalities. So these functionalities could be, for example, location. So it can be located. It has a typical camera functionality. It might be even have a motion detector. Once it senses motion, it starts recording these sort of things, and many other function blocks. So these functional aspects, we break them down in information models and so-called function blocks, and they are reusable components. So if you might take another example here, for example, a car, which might also have a location, right, to locate a car, you would reuse the function block location in this car information model. So information models support different kind of use cases, and some of the use cases we're going to be covering in this rapid prototyping demonstration. So one of the use cases are to generate code templates for connecting a device to an IT platform. So that piece of code can be translated or can be converted from an information model from these properties into properties and source code which runs on the device itself, or it might be on a gateway if the device is not capable of speaking directly or is IP enabled. On the other hand, you can use information models for simulating a device, so by sending test data to an IT platform. Also, that one is something I'm going to be showing you today later on, how that is actually possible. When you would like to consume the data in the backend, so on the one hand side, you have the devices sending out the data or being actuated to fulfill certain functionality. On the other hand, you have the backend IT applications which consume this device data. So even those can be generated from pre-configured application templates. The Another use case is to use information models for auto-detecting devices. So that would work in a way that you can resolve information models, therefore the metadata of devices, by specific technical IDs. So let's take an example of Bluetooth, which transmit, for example, in a get service, the device information profile, which contains the model number of that specific device. So that model number can be sent over to the repository, which maps it to an information model and returns it back to the client application, so it knows what device it actually is. On the other hand, you can use Vorto models to visualize the device data in a standardized way. So location, for example, can be standardized to be rendered in a map, in a Google map or so, or accelerometer could be represented in a bar chart. Last but not least, you can use models to validate device messages. So you want to make sure that the data that you send to the device is actually something that is valid. So you can use the information model to validate that. Okay, let's get started with the demonstration. Here we'd like to implement the following Hello World application based on the EclipseIoT stack as well as the Bosch IoT suite. I would like to consume a laser measurement device. This laser measurement device is from Bosch Power Tools. It's called Bosch GLM, and it's able to measure a distance via laser technology up to 100 meters, as well as the inclination. So we'd like to measure the data, for example, a floor plan with length and width, and transmit this data via Bluetooth to an Eclipse Cura gateway. This Eclipse Cura gateway then transforms this data and sends it out to the Bosch IoT Suite cloud backend. The Bosch IoT Suite cloud backend, there is the digital twin components called Bosch IoT Things. It's powered by the open source Eclipse project Ditto, which stores the state information of the GLM and provides this to other applications northbound. So in this northbound applications, we're going to implement a GLM dashboard to visualize the distance data as well as the incline data of the GLM. Last but not least, I would like to use a voice control service from Amazon, the Alexa service, to ask the GLM what the distance is, and Alexa would respond with the actual value. Okay, let's get started to build this with EclipseIoTVorto. So the first thing is we need to do is to create an information model to basically describe this Bosch GLM 100C device. It consists of two pieces of functionality, the distance sensor as well as the inclination sensor. So these two function blocks we're going to model, and then after we're done, we can publish this model to the Vorto repository to continue in our demonstration. Let's switch to the new EclipseIoTVorto web editor. So it's a complete new online-based editor to describe devices. You might be familiar with the Eclipse toolset to do that. So now this is a complete new component here. You will need a GitHub account to sign in. So I can just sign in here. Then you see the project overview. So I can create a new project. Call this, for example, Virtual IoT Demo. Create a new project. Then it directly brings me to the project and resource browser. So on the one hand side we have the file browser explorer to see all the models that we're going to create. In the middle part is the editor to to describe the device, as well as on the right hand side is the models we would like to import in terms of if we would like to reuse certain function blocks for describing a device. So let's go ahead and create a new model, a new information model. We are going to call this Bosch GLM 100C. This is the device we would like to connect. Give it a certain namespace, as it might be, the version is sufficient for now, and we can give it even a name here, a description, Bosch GLM 100C, and confirm with a submit. So now it directly opens this model in a DSL editor, and we can get started on describing. So the first thing we're going to do is to create the distance sensor function block. So we can create a new one, function block, name it distance sensor, give it a namespace, and give it a description, and confirm with create. That opens the distance sensor function block, where we can add status information. So we know that the distance sensor of the GLM is able to provide us with the actual distance value. We can define here the distance, and we know it's going to be double. We can even provide the constraint, so this distance value will be between 1 and 100, as the GLM is able to measure the distance up to 100 meters. So you can say min 0, max 100, as well as give the actual unit. So we can define that as an optional property. And we can define, so it could be inches, it could be meters, depends on what your settings are in the device. Let's save this model. So the rest of the other properties, configuration, fault, and operations, are not required at this moment. We can switch back to the Bosch GLM 100C information model and drag this distance sensor onto the device. Now we have the Bosch GLM described with one distance sensor function block. As we know, it also has the inclination, so we don't have to model this. We can browse this in the model repository. We're just typing in and search here. We'll find it, the incline sensor, that's the one I would like to use, and click on the import button to import this model, and it will be directly referenced in the Bosch GLM 100C information model. I can format my model here by pressing Ctrl-Shift-F. Looks a little neater. Now we can also save this. So once I'm done, I can click on Publish and publish the whole model. You can see here an error, and this is because the information model repository already has a Bosch GLM 100C, and it will tell you this model already exists. So if we cannot publish at this moment, so we'll have a look at that. We can have a look at this model. It's already here. We already added a nice little picture as well, and you can see the DSL containing the distance sensor and the incline sensor we also described just now. In a second step, we would like to register this GLM in the Bosch IoT suite. So basically pre-commission it, and so we are able to read and write data. We do this via the Bosch IT Suite Developer Console. It's a development tool in order to pre-commission this GLM very easily. So what it does behind the scenes is that it takes the GLM information model and reads its metadata and creates a new Bosch IoT thing in there as an instance, and attaches also the corresponding ACL, so only the specific user creating or pre-commissioning the device is able to read and write data. Okay, let's do that. Let's switch to the developer console. And here you can see the developer console thing console. I can click on connect a new thing and type in the GLM. It brings me right to the Vorto information model we just saw in the Vorto repository. This is the one I would like to connect. I click on next. I can choose how this device communicates to the Bosch IoT Suite, in this case HTTP. I can give it a namespace. We'll leave that as a default and give it a certain name. I would like to and a technical device ID, which could be the model number of this GLM. Last but not least, I confirm with a complete, and it has successfully registered now in the Bosch IoT Suite. I can click on details to load this instance, and it's telling me already that it has certain data that's retrieved from the information model, initialized with certain default values, and now I'm able to alter this Bosch IoT thing instance, as well as read from it. So now that we have an instance in the Bosch IoT Suite already provisioned, we can write a backend application which consumes data and visualizes its data in UI widgets. Vorto provides a web dashboard generator which creates Spring Boot code templates and the connecting functionality to the IoT Cloud backend. So on the one hand side, it generates device data visualization supporting different kind of widgets, for example map, gauges, and bar charts. You might be wondering how it would know how to render a function block either as a gauge or bar chart. So this information is stored as an optional mapping inside the Vorto repository and a UI mapping. So UI mappings declare that the distance sensor is supposed to render, for example, in a gauge. So the generator produces then a Spring Boot app. You can even choose to the Spring Boot app to have Swagger documentation. It supports authentication with Google OpenID, as well as if you choose Bosch IoT Suite backend, the connectivity to Bosch IoT permissions. You would like to eventually like this application to store the data directly in a database, as well as all the historical data coming through, and would like to run analytics possibly onto it. So you can choose that you would like to also have a historical data persistence created for that. Let's have a look at how that looks like. So the first thing you need to do is to go into your Bosch GLM 100C information model in the Vorto repository. And on the right hand side you see all the available generators. You see quite a huge list, So you just have to find the web-based dashboard. So here you can choose certain add-ons you would like to generate. By default, it generates always the data visualization as well as single sign-on with Google. But you can also now choose, I would like to have persistence of the data as well as the Swagger documentation. And the cloud platform connector to get where to get the data from. If you leave that blank, it will create a dummy implementation which you have to implement in order to retrieve the data from your custom backend. But here I would like to choose the Bosch IT Suite to fetch it from there. You can click Generate, which generates me a complete bundle, a zip bundle, which I can import into my Eclipse as a Maven project. I already had done this here, and as you can see, it had created the model from the information model. So if you click on the distance sensor status, this might be looking familiar to you as we just described it in the web editor, as well as it creates a persistence for this GLM, and I'd like to also it fetches an interface for data service to query, as well as getting the thing data from a specific backend. The backend, so we have chosen Bosch IT Suite to will create a backend implementation to get it from there. If we start this application up, you can directly start it up. It will look like this. So you can log in now. Either you can log in with Google. In this case, I would like to log in with the credentials that have been given to me by the Bosch IT platform team. So I can just sign in. And it already, now it had found the Bosch GLM's 100C instance that we had created via the developer console. And if you click in there, you can see that it had created UI widgets for the distance sensor as well as the incline sensor. It as well had created a Swagger documentation. If you click on Swagger, you can open this and you can search the devices directly in the Bosch IT Suite for your solution and find here the Bosch GLM 100C, which had found that one instance with so far no data yet. So that's what we're going to change in the next step. So in the next step, we would like to test this backend web application. For that, I like to use the GLM simulator, and this GLM simulator I can generate that from the GLM information model as well. So the backend developer can test his backend functionality and behavior without having the actual device at this point. So as it complies, the data complies to the information model, it is well understood by the Bosch IT things and sent over to the GLM dashboard via WebSocket technology. So let's go ahead and do that. So I go switch back to my repository here. As it looks already familiar to you, I can click on Bosch IT Suite, click on Device Simulator, that I would like to use that, and click Generate. Now it had created also a Maven project, which I can import into my Eclipse, which I already had done. So if you click here the Bosch GLM 100C simulator, you can see that it had created me also the function blocks, distance sensor and incline sensor to send as a model, and a client with a main method to execute. So I can click here to start this up, the simulator. Now it's sending data. So if we switch back to our web application, we should be able to see the data coming in. So you can see here the data is coming in from the device, from the simulator via Bosch IT Suite. Okay, let's stop this simulator. The next step, we would like to integrate the actual GLM device, and we would like to use Eclipse Cura for that, as it has a nice gateway framework with Bluetooth support in order to read the data with a Bluetooth driver from the actual device. And Vorto provides an Eclipse Cura blueprint generator. So this generator already creates you a template using the Bluetooth functionality of Cura, as well as provides an API, which is a strong type model derived from the information model that you can use, and it's implemented to connect to the cloud backend, in this case the Bosch IT Suite. So let's go into the generator. So we can open up the EclipseIoTVorto repository, find the Bosch GLM100C, and find in the list of generators the Eclipse Cura generator. So click this, you find some more information on what this generator does, as well as you can choose now the driver that you would like to use. In this case, Bluetooth is supported, and the cloud connector platform. So in this case, Bosch IT Suite, and generate. I already had done that and imported it into my workspace. So here is my Eclipse Cura workspace. I already had imported the Vorto generated Cura bundle, and if we go and open this project up, you can see as we open up this project, we can see some more information. What had generated? It generated a Bluetooth finder, which finds all GLM 100C devices, and it also has properties specifically for the functional blocks that we had measured. For example, here to enable the distance sensor, to enable the incline sensor, and the Bosch GLM 100C device. Once it found one, it creates an instance of this device where it be able to or it generates a function which you would have to implement here as a to-do to read the value directly via Bluetooth GET and convert it into the incline sensor model. So Cura has a nice little feature, which is an emulator to emulate the gateway, and loads all the OSGI bundles in it. So let me start the Cura emulator. The emulator provides an HTTP interface, a web server, so you can directly open it up in the browser have to authenticate here with standard password. And as you can see here, it loads services which are built in, as well as our generated OSGI bundle for the GLM. If you click on that, you can configure properties, for example, on the one hand side to communicate to the Bosch IT Suite backend. Here you have to add in the solution ID to identify your tenant in the Bosch IT Suite backend. The endpoint, which is by default already populated, and some other values like the scanning period, etc., as well as specifically for the function block to, if you would like to enable this or disable that for Bluetooth scanning, to send this data also to the backend, so you can activate this. So once you have implemented the functions to read the values from the GLM via Bluetooth, you is able to send the data in the specific interval to the Bosch IT Suite, and we know that it can be understood by the backend web application as it complies to the same information model. Last but not least, we would like to add voice control. We can do that using the Amazon Alexa Skillset. So Vorto creates an Alexa Skillset, the Lambda Node.js function, and the interaction model, meaning the schema for the GLM, which is needed in order to instruct the Alexa service how to translate voice commands into technical commands like REST calls. So this is completely generated out of the information model as well. So you'll be able to ask Alexa to say what the distance is, and Alexa would read the value from the Bosch IoT things and return it back to the user. So let's do that. So that once again is Vorto generator. So you can find that via the Vorto repository. You can click on the Bosch IT Suite and find the device voice control. So here you can say, yes, I would like to generate that, and click generate. With this generated bundle, it generated a Lambda Node.js function. So if you open up your Lambda management console in AWS, you can directly drag and drop this generated code into this editor here. And if we scroll down to one of the functions, does it look familiar to you, what we have modeled in the Vorto information model? The distance sensor distance, which it goes to the backend, to the Bosch IoT Suite, and reads the value and defines this as a speech output, which then is returned back as a callback to the Alexa to speak the result. Do that for the distance sensor. So you can test that really nicely. You can just go to the Amazon Alexa test infrastructure, service simulator. So if you click here in the text input field and enter the utterance that you're interested in, for example, what's the distance? It outputs the distance is 49. If we want to compare this to our web application who retrieved the values from Bosch IT things, it's 49 meters, so that's correct. If we ask Alexa to give us the incline, it should be 41. So let's go into our console and ask for the incline. And you see the incline is 41 in the output. To sum up, with Vorto you can get started with IoT projects very quickly. And this is because you can use a lot of generators which are out there for you for many different technologies and IoT platforms. So you can just click on them and generate source code directly from your Vorto repository, as we just saw. It even supports parallel development. So if you, we saw in our demo, the backend developer can start writing the backend code based on the GLM information model, whereas the embedded developer or gateway developer can focus on integrating that device to the platform. And as they all agree on the same information model as this type of interface, they wire up very nicely. And you do not need to install any bundles. So as its entire Vorto platform is entire cloud infrastructure, you can describe the device, you can publish it there, you can generate code directly from the Vorto repository and import it in any IDE of your choice. Feel free to contribute to the project. I added here a link to our GitHub source code repository. Or if you would like to also just upload your device, or if you want to describe your device and upload it and generate code, feel free to do that. Here the Vorto repository is hosted on Eclipse, vorto.eclipse.org. And get started with generating for various different platforms. We keep on adding more technologies which are to it. So stay tuned for many more generators in the future. I say thank you very much for your attention. It was a pleasure for me to introduce to you EclipseIoTVorto today, and I hope you could get something out of it for your next project. Thank you very much, and bye-bye.